Glenton Gates is a Chief Information Security Officer, Security Chapter Leader, ING Belgium. So this is the second time he'll be coming to speak with us in our community. And we'll also be taking us on the SKF Learning Platform. There has been some improvements, upgrades since he spoke about it with us. So he will be coming on now to also share some new things in respect to the platform. Glenn, are you with us? You have the floor.
Yeah, I'm here. Thank you. All right. So, hello everybody. Thank you for joining my talk. Indeed, it's like the gentleman said, I'm going to demonstrate a bit the new features that we developed in the Security Knowledge Framework. Maybe also good just for the people who are not aware what is SKF and how can SKF help you in your secure software development lifecycle. Let me also share the screen, because only looking at my face will not learn you anything. Can you see my screen?
Yes.
I hope you see the Security Knowledge Framework website. Is that correct?
Yes, I can see it here, but can you make it a little bit bolder?
You want to be zoomed in?
Yes.
All right.
I think that's fine.
Yeah. All right. Cool. So my name is Glenn ten Kate. I'm the security chapter leader of ING Belgium. Next to that, I'm also very active in the open source community, and especially around the Security Knowledge Framework. So the Security Knowledge Framework is a OWASP flagship project that I created together with my brother, Ricardo ten Kate, around 7 years ago. And since the creation, we kept improving, extending it, and adding more features to it. So the Security Knowledge Framework is basically like a toolkit for you as a developer or your security AppSec person that wants to do more in depth about secure coding, security, and really building applications secure by design. So we created this project with the idea to really help and guide developers in building more secure applications. SKF itself and everything you see is, of course, open source. So for the people who are interested, here you can find the source of the application, and it's basically having all the stuff that I'm going to show you is there in the repository as well. So, like I mentioned, SKF, we created it because we wanted to help developers in building better and more secure applications. So we started out with basically the checklist. By default, from SKF, we have the web application checklist and the mobile application checklist. And both of these are actually based on the other great OWASP projects, the ASVS, the Application Security Verification Standard, and the mobile for the Mobile Application Security Verification Standard. So again, also those are like OWASP projects that are very well known, also flagship projects, that we incorporated into the SKF. Now here, as you can see, we have a web application, SKF, and in there we have these requirements. So you can go to the different categories, right, of the checklist. So the first category would be the architecture, design, and threat modeling requirements. And these are basically all your security requirements in the category of architecture, design, and threat modeling. So as you maybe know, the ASVS works with different levels, level 1, 2, and 3, where level 1 is the step-in model, and level 3 would mean if you build really critical applications that you would use level 1, 2, and 3, basically all the security requirements in the ASVS. Now, as you can see, these are only the category for the first ASVS topic. And they're already quite extensive, right? There are already quite some requirements for only this category. Similar, with the authentication, the session management, the data address, data in transit. They have many, many security requirements. And from a application point of view and building a secure application by design, you actually also need all these requirements, right? For the beginning, when you do, for example, a new project, it would really be beneficial to use this ASVS as your security requirements. Of course, you need to modify it a bit because some technology you're not using or some design architectural in your application you're not applying. So some of the requirements can be, removed, but you do need to modify it a bit so it fits your organizational need. Now, when you then start the project, you use the checklist and you implement these type of security requirements that are listed here. Now, the question is, when you do that, that's nice, so you have a baseline, but every time you build a new feature and new code is being added, you should also check which requirements you need to implement. Now, what we did in SKF, we made that part a bit easier because we created a sort of expert wizard. And in this expert wizard, what we can do is basically generate requirements based on a sort of expert wizard. So the idea is, let's say I'm going to build a new feature for my application. I want to build a search function. Now, I will go to the projects, select my project. I will go then say, hey, I'm building a web application. I want to use that checklist of security requirements. Then I will say, what is the maturity level? Well, let's say it's a very critical application. So I will use 3, right? The advanced for in-depth security, for example, military, health, safety, critical infrastructure, government, that type of stuff. So I say level 3, and then I select the different categories that I'm interested in. So remember, I'm going to build a search function. So I definitely need to do things with validation, right? So let me click that category. Next. And as you see, what we did, we built like this questionnaire expert wizard. Yeah. And based on the answers we give here in this wizard, the SKF platform will now select from the 290 security requirements in the ASVS, only the ones that are applicable for our feature, the search function that we're going to build. So instead of going through all the 290 security requirements, we just have to answer a couple of questions. And based on that, we get the feedback which security requirements we should think of. So, for example, do we want to have input validation requirements for parameter binding, URL redirects, validation of things? Well, I think that is always good to have. Are we going to output user-supplied info? Well, yes, because we're going to search and then we're going to reflect what the user searched on. So we say yes. Are we getting files from the local system? No. Are we going to select something from a database? Well, yes, we're going to search in a database if we find something. Using LDAP, no. OS commands, no. XML, no. And are we going to do deserialization? Well, we're going to use maybe JSON, so let's also say yes to this one. So basically, now we can say, hey, this is a new feature that I'm going to build, the search function. Or we can say, hey, I want to enrich already a feature that I had before, but with additional security requirements. But as this is a new feature, we are going to, I always say we're going to just add it, right? Create a new one. So next. And now you will see when we do submit, SKF will correlate all the right security requirements for that search function that we want to create, and then display for us only the security requirements that are actually needed. So as you can see, it now selected a handful of security requirements that are based on the feature, the search function, that we will probably need to also implement with our other requirements, right? So, for example, we see here the security requirement from the ASVS 5.1.1 verify that the application has defense against HTTP pollution attacks. Yeah, especially against framework that does not make any distinction about the source of the request parameters, get, post, cookie headers, and variables. Or the other one, verify the framework protects against mass parameter assignment attacks, right? So, for example, .NET, Laravel, Ruby, they all have these mass parameter assignment vulnerabilities, could be, right? Another one, verify that all input, yeah, headers, batch, everything is validated using a positive validation, aka whitelisting. Here, another one, output encoding, right? Why is that important? Because we don't want any cross-site scripting vulnerabilities. Setting the right output encoding. Preventing cross-site scripting. Oh, you're going to do something with SQL, right? Database queries. Please remember to use the parameterized queries, right? So we don't have any SQL injection. Well, as you can see, so here we get already a whole list of security requirements that we need to take into consideration when we're going to build that search function. So we combine the checklist. Checklists are easy and reference material. So you can just click on session management and look very quickly like, okay, I'm changing or doing something with session management. Do I have some missing requirements or things I need to consider? Or the other way to use it is really using the project. You select your project, you generate your requirements by going through this. And after that, you will get the results with your security requirements, right? So then you know at least, hey, these are the things I need to consider when I'm building this feature. The other thing we did in SKF is basically also having code examples. So we have code examples for the most common functionality and features that you would build in your application, like an input validation, how to do audit logging, how to set up a privilege-based authentication, open redirects. Well, you see it, most of the core features that you would need or build in your application are also mentioned here as code examples. And we have them for ASP, Java, Python, Django, Flask, PHP, .NET. So the most common languages, I would say a couple of Go, Ruby, how to approach certain things, right? So again, giving you very detailed advice on how to do something. Well, in this case, it's very simple, like the XSS protection header, how to do that, and the encoding, but also, for example, well, let's go back to Flask, for example, SQL query. So how do you do a proper SQL query in Flask, right? What to do, what not to do. As you can see here, parameterized values and queries, right? Replacement variables. So that is all good. So here the idea is really to give you more in-depth knowledge about certain implementations as well. Then we have the other section that is the knowledge base. And basically this is a mixture of the Mitre knowledge base section and the knowledge base items that we wrote ourselves. As you can see, it's quite a lot. I think it's like over 400 different knowledge base items. But again, some very short, others way more in depth. Let me see if we can find one that is really more in depth. Reliance through op security. Remember, probably we had this issue or this talk quite a lot with some people. Like, hey, okay, you're building a security mechanism, but it's based on op security, right? Because if somebody pokes through that op security, then your whole security fails. For example, remember the nice port knocking technique. So normally when you would nmap a server, port 22 would not be open, so you cannot SSH into the box. But if you first knock the port 111, then 444, and then 1337, then the SSH port will be open. Yeah. So this is what we actually call security by op security. If somebody knows that step and that trick, then your whole layer of security is gone, right? So just to give you an idea, a lot of jargon and principles and specific security jargon, can be found here, and you can also search for it, right? What it actually means, like an empty synchronization block. What does it mean, and what should you do as a developer, to mitigate or counter this vulnerability or this bad practice or this security issue? So the knowledge base is quite handy to look up specific words, jargon, or stuff you're not familiar with, and you can have that information in one website. Also, what I didn't show yet, but we also have a machine learning chatbot that you can deploy in Microsoft Teams or Slack or whatever chat channel, and it can also query these knowledge base items. So you can basically ask the chatbot, hey, what is an HSTS header? And it will then mix and match with one of the knowledge base items, and it will tell then the description of the knowledge base item. If you then would ask like, hey, how do I solve or fix or implement an HSTS header, then it will give the part of the knowledge base item that had the mitigation, right? As you see, not every item has a mitigation because some are just an explanation. They really don't need a mitigation. But other items do have mitigations, and then the chatbot will actually explain that part. Again, this chatbot is also open source. You can deploy it in your organization to easily consume a lot of information without going to the website, but just query the chatbot and it will give you the answers. Now, the other thing we already had a while in SKF was the labs section. So in labs, you can basically search for around 70 to 80 different labs that you can start and actually practice your security skills. We currently have like our own labs, the SKF Labs, as you can see. So these are all SKF Labs, and we also have included JuShop. So from SKF, you can also deploy an instance of JuShop and start doing the exercises in JuShop. So what is JuShop? JuShop is again another OWASP project, right? So let me see here. Well, that's the solutions. We don't want the solutions. We want to keep the solutions over here. So again, a great OWASP project, the OWASP JuShop. And again, here you can really practice all these security vulnerabilities in an easy, friendly way and learn about AppSec. Like I mentioned, so what we can do in the lab section, we can just say start. And what is now happening in the SKF background, it's sending to the RabbitMQ a message saying, hey, I want to deploy this lab environment, pull a Docker image and deploy this Docker image in a Kubernetes stack so we can actually then access it. So we copy the link, we paste it in the browser, and boom, here we have our own instance of JuShop running, which you now can hack, practice your skills, and well, do all the labs that go with it. I think JuShop has around 120 different security vulnerabilities that you can practice and do. So it's a great resource for learning more about AppSec. Of course, when you're done with the lab, make sure you stop it because otherwise it will consume resources and that will be a pity. And again, so the whole labs environment is about learning. It could be that you're maybe stuck, right? So let's say we're going to do the path reversal, the local file inclusion lab. Let's also start this one. And let's say you're maybe stuck with it and you're not sure how to continue. Then you have here in the README section, the different labs that you can look into to see what are the steps to actually find the vulnerability and what is the next step to test for the vulnerability. So we're going to click on the Python and here you see, okay, reconnaissance. What do we need to do? Local file inclusion is the process of including files, etc. And when the developer didn't program their application correctly, we can actually use the ... technique, the path reversal, to traverse back to the document root yeah, and then read the ATC/password file. So we basically can select any file from the server and read that in to the application that then it will display to us. So if we go now here, you see the lab has been started. We go there. So now we have here the lab, which contains a local file inclusion vulnerability, right? A path reversal. Well, of course, first you will just, exercise the function. You see, when I select the drop down, it will select and give me a different text. So, okay, let's see if we can actually exploit this. And again, if you're not sure, right, how to do so, you can always follow the write-up where this also explains step by step, right? Of course, for me, I did this 100,000 times, so I can dream this. So in here, we have our selection, the menu item where we can select things. And if we inspect the HTML, we can see that the option values are actually a path pointing to a file location. You see, text/intro. So if I make it now fullbar.txt, right, that is probably something that's not existing for the option intro, yeah, and I submit this, you will see now we get an error saying, hey, no such file or directory, fullbar.txt. Now we can also scroll a bit down and we see that our error here is being raised in this last function over there. So basically, the file name will contain exactly what we are going to give to it. So meaning, if we indeed change the value here in the intro, yeah, in the select option bar, then this value will be selected. So, for example, if I now indeed do the path reversal technique, the .. then instead of loading the intro.txt, it will actually load the ATC password file, as you can see. How awesome is that? So the path reversal using the .. in this case, in this application, because the developer did not any validation or whitelisting or anything, we actually can abuse the functionality to read any file from the system. We could also do like a denial of service attack, right? If we read the /dev/random, it will continue to load and load and load till the memory of the computer has been reached the limit, and then we get a denial of service attack. Now, like I mentioned, in the error that we saw before, our user input is directly being used, right, in the file open method. You see, fullbar.txt error, and what is the error line in the code? This one, file name. So our file is directly going to be placed in the fopen function. Now, the cool thing is that actually for this lab, it means that we don't actually have to do a path reversal. Because by simply just changing this value to ATC password, we get and receive the same result, right? Because whatever we supply is directly inputted in the open function, the file open function. So this is a nice example on, how you can actually use the different labs to practice the different type of vulnerabilities, right? And again, here you have the writer that also really step by step explains what the problem is, what we can do with it, and how you can validate and test yourself. For most of the write-ups, for most of the labs, we actually have write-ups. They go from the OWASP top 10 type of vulnerabilities, right? The local file inclusion, the SQL injection, the cross-site scripting, but also very advanced things like the race conditions, the JWT vulnerabilities, the GraphQL different vulnerabilities, deserialization, server-side request forgery, template injections. All that good stuff is also part of this lab environment. So here is a great environment actually to play and do the labs on your own. Now, the most recent thing that we actually did in SKF is we were building the last 2 months, 3 months, we're building this new capability. It's the training platform. So instead of you just doing specific labs and having some write-ups, we actually created a whole track of different profiles, so to say, that you can follow. So for example, hey, you're a developer, you want to learn about secure development, then this course is for you. Hey, you're an AppSec guy or a security tester, or you're already a developer, a secure developer, but you want to be more on the offensive side to better understand the vulnerabilities, then you can do this profile, right? The hacking web API. The infra ops is very for, ops and infra people who set up machines or infrastructure and configure them and do the patch management and all that good stuff. And then we have a last track and profile. It's about OWASP. So here in the future, you will find the different type of OWASP projects that we have. Currently, we only have the OWASP Top 10, the 2021 release in here, that you can do as a course. But in the future, we will have here as well the OWASP Zap testing, the OWASP dependency check and tracker, and all the other OWASP projects will be here as well as courses that you can do. So how does it look like? Well, let's say we're going to do an OWASP course. We select the profile OWASP Top 10. Here you see the different information about the OWASP Top 10, right? And you can go next.
Okay, let me just make sure the clicker is doing the clicker.
What is also important that in some of the chapters, you will have like a YouTube video that gives you more, understanding about the topic, or in this case, about the OWASP Top 10, right, by Andrew. And then when we go into the subcategories, you have here the content and the information, right? We can also go full screen, so it reads a bit easier. And here we can follow the whole content of the OWASP Top 10. A lot of information, of course. Well, let's go next. How to use the OWASP Top 10 as a standard. Well, not. Different stages. About OWASP. How to use Zap. Quite important. If you going to test for the OWASP Top 10 vulnerabilities, for example. So here you have some explanation how to use Zap, how you can start it and point it to an application. And here we are in the A01, the broken access controls. And again, what are the broken access controls? What should you do to prevent them, right? Some example attack scenarios, references to other websites where you can, again, get more information and content about the issue. So that is that. And again, we can go over the whole course, as you can see. Now, what we also have is we created this more advanced lab environment. Because the lab that I just showed you about the local file inclusion, right? The local file inclusion lab, that's a nice lab, but you're still a bit limited in what you can learn and what you can do. So what we actually did, we created like this other lab environment where you have more freedom. It's basically an operating system that is fully running within the browser. That means that you don't have any hassle of, any hassle of starting or running or installing tools or scripts on your local machine, because everything, is available in the other platform, in the browser. So you don't need to install like Python, or if you want to do a Java lab, or you don't have to do all that good stuff, because everything is now running within the browser. And like, a normal operating system, you have like a terminal, you have, Firefox, right? Because if we're going to hack web applications, we need to have a browser for that as well. Let me open a new desktop, and also let's start Zap, because we also want to use security tooling to detect and see if we can find vulnerabilities. So we can start Zap. Going to the next screen, I'm going to open the editor. So we also have an editor. There we go. Start a fresh Zap instance. And why is this new operating system so interesting? Because it gives us the flexibility to learn about offensive security, right? Just like we did with the labs. But now we can also test and play with tools, right? And how to configure them properly to make sure that we can use them in our CI/CD or in our daily operations, right? In our day-to-day work activities, in a safe and good environment. So let's go again to the same lab that we did before. We will go to the labs, not that one, labs, and we will go to the local file inclusion. Yes, open. So as you can see here, here is the code of the lab, the local file inclusion lab that we just did in the SKF application. And the good thing is we can alter the code, we can change it, and we can also run the code then. So let me go to another tab and open. Say the Python lobs, local file inclusion. We need to install the requirements. Otherwise the app will not start. And now we can start the lab. So you will see it's now running on localhost port 7000. So if we go back to our Firefox here, localhost 7. Here we have the same application, right? The same lab that we just did before in the labs environment. So as you can see, in this hacking operating system, this new learning and training platform, you have everything conceived, everything in the browser itself, and you actually don't need to install or circumvent any company policies or whatever to install tools on it. Everything is contained in this lab environment. So now we can actually do the same thing, right? We can do inspect, we can hack the application, like here, change, it is a password day, and when we do submit, we will see we have now again the password day file. All right, so also what is important, that we know how to exploit those things, but also how we can use it using automated security tooling, right? So for example, we take Zap, over there, we take Zap, and we go to the automated scan. We say here, local host port 7000, and we say attack. So it will first spider the application, receive all the URL paths, and then as you can see, it's scanning and enumerating the application and to see what are the actual attack points that it can use to attack the application. Let's see in the alert. So here in the alert are actually all the findings that Zap has found. And as you can see, it found a cross-site scripting reflected vulnerability. This is in the 500 internal server error page. Also, it found a path reversal vulnerability in /home. You see? Here we can see what the response header was. Here we can see that it actually succeeded in reading the ATSA password A file. We can also look at the request that Zap did. So it did a post request to /home, change the file name to ATSA password A. Please remind, this is URL encoded, right? So this would be /ATSA/password A. And with this request, it found the response full with the ATSA password A file, and it flagged it correctly, as you can see, saying, hey, we have a vulnerability here. Now, my question to you guys is actually, what should the developer do to fix this issue? So what I see sometimes is, for example, that somebody says, oh, okay, I know about the ... vulnerability. Let me replace, yeah, if I see a ... let me replace it with nothing, right? So let's also see if we can build in something similar like that. So let me Google. Let's see, accept. Yes, so it should be something like new file equals replace file name dot replace, and then we're going to replace the ... with nothing, right? Because this is a developer, this developer knows about security issues, and it knows like, hey, there is this pod traversal vulnerability. So let's fix it by replacing, if I see the ... let's replace those with nothing, right? So we don't have a vulnerability. So we're going to save this. Then let's see. We started the lab. It reloaded again, so that's good. We're going to clear. This. Let's see, delete. Yep. Quick start. And we're going to start the attack again. Let's see if this solution actually helped and fixed the vulnerability. And also in the meantime, what I can do, because we did it also by hand, let's here again do the ... and see if it indeed worked. So it didn't work, okay. Now let's also see if Zap found something. It looks okay-ish, but not really. Because what is now the problem if we do this, the ... what is here the problem? What can we do as an attacker to circumvent that? So the bad thing is, and it was in one of the courses as well, and in one of the security requirements, make sure when you do input validation, it's always against a positive whitelist, right? Not a blacklist. What we just created is basically a blacklist, because we say, if we found this very specific string or characters in it, then we're going to change the data and remove it. So this is a blacklist approach, because what the attacker now can do is ... // And let's just submit this, the dot 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 slash slash, yeah, and see what will happen. As you can see now, the dot dot slash dot 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 slash slash is now being converted to dot dot slash slash. Are you guys following me? So how is that even possible? Well, look, if the attacker, yeah, injects this, yeah, so this is the input, then we're going to replace from this string all the occurrences of dot dot slash with nothing. Then we end up with something like this again, right? Because it removes dot dot slash dot dot slash. You see? So we end up with a valid syntax that we can use to open any file that we want. All right. So making a blacklist approach is never a good idea. We shouldn't do this. So what should we do? Basically, what we should do is minimizing the attack surface. So the first thing I want to say is, why do we give the user the full access, yeah, to select also a path? Yeah, this could actually be removed, yeah, outside the reach of the user. And when we open a file, we can just simply add it here, right? So we don't have this already in control of the user. Now we only have this. To again minimize and making it harder, we can say, hey, we're also going to remove the extension, because why should a user be able to select his own extensions, right? So now the input is this. And basically, if we look at the three different options, chapter 1, chapter 2, default, and intro, we could even make now, yeah, using this technique, we could even make a simple switch statement or if else then statement, yeah, where we hard code these values. And then if it's that value, we're going to load it in here. And again, this is all about minimizing the attack surface and also making your application, you know, keep it simple, keep it stupid. The more simpler and stupid it is, right, the easier it is for you to defend your application. Also, let's say we're not going to make a whitelist, yeah, and a switch statement. What we could do here is say, hey, regular expression, yeah, regex, if it's an A to Z, 0 to 9, yeah, then it's okay. Then we're going to open and read this. Yeah, then we're going to do this. If it's not, right, if that's not the case, else, then we say reject, oh, Ctrl Z. Then we're going to say reject user input. We go into the error HTML and we say error invalid user input. Because that is the other principle, yeah, that you should never work upon the user's input. You should, if you get input that is not what you expected, you reject that user input, right? So we have a regular expression on the file name. So if file name regular expression is A to Z, uppercase, A to Z, lowercase, or 0 to 9 digits, then we're going to access and read it. Otherwise, if it's not, it contains something else than these characters, we're going to say, sorry, invalid user input. So again, a defensive principle, right? How to handle user input using a whitelist And also, like we saw, we just refactored a tiny bit the code to make it more stupid and easier, right? Keep it simple, keep it stupid, because validating just a word is way easier than I needed to make a regular expression, right, for that. If I didn't do the rewriting of this, now I needed to be allowed a forward slash. So that could be already a bit tricky, right? But actually breaking it up like this, now we only expect the word default, intro, chapter 1, chapter 2. So we can use this as an input validation, right, to prevent any injections. All right, so let's also do another one. Let's go to the SQL injection. Everybody loves SQL injection. And something we still find day in, day out, because apparently it is quite hard to get it right. Let's do the SQL-like. Open. So we have here an SQL application. This is Zap. It's going to be closed. Okay, this one is still running. Where is it? It's here. So we go now to the SQL-like. Let me install the requirements. And I need to change the port. By the way, some of the things are already fixed. This is an alpha release I'm currently using, and that is on the demo website. But the one that I have locally contains already a lot of bug fixes, like the port. There's also a script in the environment in this operating system where you can run actually all the labs, so you don't have to know the commands or anything. You just say, hey, I want the Python cross-site scripting lab. It will do and install all the files for you, run the application for you, so you don't have to do any of those things that I'm currently doing, to make it even a bit more easier. So we now started the SQL lab. It's running on port 7000. So if I go here now, you see almost the different overview. I mean, the same overview, but just the content here in the middle is different. As you can see, this is about SQL injection. Well, first I'm just going to use the app. We have 3 links, as you can see here. I can click on them, and then the user and the email address is being displayed. Well, this is an SQL injection, so I think we need to do something here in the URL. As you also can see, when I search for pleb, it will still give me the user information of plebeian, because basically what we fill in here will end up in a like query, yeah? So that means a sort of search statement in SQL. So we have here the app. When we first will try a single quote, and we will see, hey, SQL-like 3 error unrecognized single quote, yeah? Single quote ordered by user ID. So we can go all the way down, and we see here the last line of the code where it went wrong. Select username, email from users where username like, and then order by user ID. So what is the problem here? As you can see, username is directly concatenated in this SQL query that's being executed. So a classical example of an SQL injection, because our user input, right, the username, is here directly concatenated. So what we now need to do is craft a proper query in the URL that will create a correct SQL syntax, yeah, based on this like statement. So what we can do is basically, we can comment out the rest of the query. So in SQLite, it is --. In Oracle and other MySQL, it's a pound key. In some other database backends, it's a different sign, but here it is --. So now the query will be select from users and username, where username is like admin --. So we now have a correct syntax. Now, the next step is also to validate if it's really true. Maybe this could be a false positive or a default that it will always result. So when I do a logical injection and 1 is 1, I get no error, so that is good. Now if I change this to 2, I'm going to be expected an error, because the left part of this AND statement is true, but the right side of the AND is false. And the AND statement, the logical operator, requires the left side and the right side to be true. Well, left side is true, but right side is not true. So this query should result into false, meaning the application will give me an error because there's no data to be shown. So let's give it a try. And you can see, and 1 is equal to 2 gives an error. It didn't give the SQLite error. And why is that? Because our syntax is still correct. It's only that because we did 1 equals 2 results into false, results into nothing being selected in the database, that it now has a list index out of range. So what does it mean? It means it selected something from the database, value 00, and wants to assign that to the variable username. But there is nothing in value 00. That's why it's raising list index out of range. And that is true because if we look at our injection, and 1 is equals to 2 means false, means nothing is selected. So with these 3 simple steps, that works on every database. Yeah, and I especially didn't use sleep or benchmark or another approach. And why is that? Because, you know, in a MySQL database, it's sleep. In a Oracle, it's benchmark. In another database, or like in SQLite, you don't even have a function like that. So that's why I always use the logical operators to validate if there's an SQL injection, yes or no. And I use the AND logical operator because I knew what the left side would be as an input. So you also have the OR statement, right? Admin or 1 is equals to 1. Now, interesting is, a lot of people don't actually understand how this works. So here, when I do this, admin single quote or 1 is equals to 2, yeah, will not give me an error page. And why is that? Because the OR statement, yeah, this logical operator works in a way that this side of the OR statement and in the SQL query needs to be false before it will execute this part of the OR. And admin is a valid user, so my injection here will never be evaluated, okay? Only when I use something that is not existing, yeah, because this will return false. There is no such username like that, so it will be false. Then it will only trigger this side, or 1 is equals to 2. So if I do this now, it will say error. If I do 1 is equal to 1, it will say you're good. Why are we seeing here the admin user? Because we didn't select the right user here. Because or 1 is equals to 1 is true, yeah, and true means give me the first record from the table we're selecting from. And apparently the admin user is the first row in the table, and that's why we see it now over here. So very important, the OR and the AND statement. Now we confirmed using this logical operator there's an SQL injection, we can do the union select, right? So admin union selects 1. Error. It has not the right set of columns, and it is correct because we need 1, 2 columns. So we go to 1, 2, 1, 2, and boom, the error is gone. It means that we now unioned the right amount of columns, as you can see, number 1 and number 2. Now we need to guess the table from users. No such table, users. Okay, users. Boom, error is gone. So we know there is a table users. Now we can guess the columns, right? User name. Admin. Good. And now password. And boom, there's the password of the admin. Now, is it a real password? No, this is a hash, right? Let's have a look. And it is an MD5 password. And it is a password 1 exclamation mark. The funny thing is that this is actually, according to many websites, a secure password. Why is that? Because look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it has an uppercase, lowercase, digit, and a special character. So most password policies would say you selected a strong password. Well, as you can see, that's not really the case. Also, it's an MD5. What is the problem with an MD5? It has hash collisions vulnerabilities. Further than that, it is also not using any salting, not any stretching, and not any memory protection. What do you want to use? You want to use something like this, a key declaration function, yeah, like archon2. Why? Because it uses a strong password, right? Assault, parallelism, so stretching, and here stretching iterations. And also you can say, if you're going to use this password hashing method, consume X amount of memory, yeah? That means if somebody has like a whole rack of GPUs trying to crack your hash, then they also need to have the additional server memory, right, to crack the hash. So now if you use something like archon2, they're limited in the amount of memory they have and not the amount of GPUs that they have. All right, so one last thing about this, we can also use limit to go over the different users. So we can do limit 2, we can go over them. And what was the other thing that I wanted to, what is also important when you use security tooling, that you make sure that the security tooling is properly configured. Because if you don't configure your security tools, then you will have a bad time. Let me see where I can remove them. Yes, delete this one, because these are all old findings from the previous scan we did. Here, delete. Yep. Now we go to quick start, localhost port 7000. Alrighty, go scan. So here we see OWASP Zap scan actively scanning for all the vulnerabilities and trying to find them. Let's see the alerts. And ideally, we should see here the SQL injection popping up, right? So it's almost done. Yep, it takes a bit of time, but then you have something nice. And as you can see, it's trying some inputs, parameters. So let's see how far it now is. And it is done. Hey, it is done, but it did not find the SQL injection. Yeah, and this is expected behavior. Again, just like any tool, you need to configure the tool properly and go over all the configurations to make sure you enabled all the features. If you just run a tool out of the box and you don't configure it, just like any software, you will miss things. Like now, we will miss an SQL injection. So what we need to do is in the scan policy, I think, let me see here, not here. We need to configure in Zap saying, hey, we want to enable, yeah, let me see, because there are many options. Here, options, cool, yeah, it was somewhere here. Here, active scan input vectors. So it uses URL query string and data, post data, but look, the URL path, yeah, is off because it could slow down testing. But we need to have this enabled. And why is that? Because in our application, the vulnerability is in the URL path, right? And that by default was disabled. So again, this is the importance, right? Why you should always check the configuration of the tool. Also in Zap, there are many plugins you can download and enable from the marketplace as well. Yeah, by default, it's not enabled, right? And if you want those additional plugins, you need to configure, download them from the marketplace, enable them, and to get really the all and the good benefit of using a tool like this. And if you don't do that, well, then you have a problem because it will not find the vulnerabilities. And as you can see now, hey, it did find the SQL injection, right? Boom. So also a good lesson learned in how to use the security tools, right? Making sure you configure them, check and configure them properly so they are able to find the vulnerabilities. Yeah, and as you're seeing, these were just a couple of labs that we did together. Of course, now I can start fixing the lab, implementing input validation, all that good stuff. Trying again using Zap to see if I mitigate the vulnerability correctly, and you can continue and work, right, and do all the courses. Now, this was only one course, right, the OWASP, but just to give you an idea, the secure development. So again, it goes really in depth about security requirements. These also have like questionnaires with them. So after a section, you get a questionnaire to see if you really paid attention, right? With some explanation as well to go with it. This deck, this is all about, yeah, secure development. So again, also about input validation, the basics, what should you do, data type for checking, text and locals and encoding, validating text. So a ton of information for you to learn on your own pace, how to do it. Again, for the hacking and web API, what did we did there? We used the OWASP testing project, right? So this is another great OWASP project. OWASP testing guide. Another great OWASP project, yeah, that we incorporated into this learning platform where you can learn all the tips and tricks on how to test certain specific vulnerabilities. So this is not only nice for developers, but also for penetration testers, right? How can you test certain vulnerabilities? How do you test them? Where do you look at it? How to approach it? What type of tools? So again, very interesting and good for you to go over and read and master this material as well. Then the last thing that I also wanted to show you is the Skf Labs. Because what we also did is, now I showed you all the Python labs, but actually we now have Infra, Node.js, Python, and soon we also have .NET labs. So here are all the labs, similar labs that I just showed you before. So here we have the local file inclusion, the same lab, but this one is basically, as you can see, a Java application, right? So same type of stuff, same type of vulnerability, but only written and built in a Java application. Okay, here the Node.js, all the labs as before, also the local file inclusion, but here it is written in a Node.js application, right? Similar issue, here post, we take the file name, and then we read the file directly what we got from the user. So here in Node.js, an example of a local file inclusion. Here Python, this is the lab we just did together, local file inclusion. And here is the lab for Python. So when you're going to do these labs as a developer, you can also pick which language you want to do it in. So maybe you're good in Python, or maybe you're good in .NET or in Java. You can then pick your own language that you're most comfortable with, and then do all the labs, the offensive and the defensive part, in your own comfort and language that you know best to work in. Yeah, like I said, currently you can find the whole training platform and everything on the SKF website, on the demo. We did not release it yet to the main branch because there are some bugs that we are still fixing, but hopefully very soon we can merge the training platform as well into the main branch, and then it will be properly available for everybody to download or to run yourself. You can of course just go to the demo website and you can play with the new training platform. So that is actually what I wanted to demo today and show you all. I don't know if there are any questions. Can you guys still hear me?
Yes, no questions.
Ah, okay. Good. Nice. Well, then I would say please play with it.
That's wonderful. That's
Sorry?
very wonderful, Glenn. Thank you very much. It's like everybody enjoyed you. No one has any question to ask, and it's really a wonderful platform, and so many things have really improved since the last time you talked about it, and it keeps getting larger and larger day by day, and is a platform I will employ everyone to get into and start using it as part of the security framework for the organization. We truly thank you, Glenn, and please always keep us posted in respect to any new features or any new information in respect to the platform, because here in Nigeria, we'll definitely use that platform for our security framework.
That would be great. Yes, we really wanted to help everybody to be able to run a secure development track in their companies that doesn't cost an arm and a leg and that is scalable for everybody, right?
Thank you very much. Thank you very much.